As our exponential growth and decay equations start to get more complicated with shifts in them, horizontal shifts, which we'll recognize as being in the exponent, and vertical shifts we'll recognize as being added to the end, they start to get a lot more complicated. And so I'm definitely going to rely a little bit more on my calculator to get these things graphed. However, there are a few things I can do without touching my graphing calculator. So let's do a few of those. If you want to skip to the end of this video, I'll show you some things using the calculator, some things to take a look for. Otherwise, let's kind of talk through a few things I can do by hand. So first thing first, I want to figure out whether this represents a growth or decay model. Remember, there's one and only one number you want to look at, and that's the base, the number with the exponent. If it's bigger than 1, it represents growth. If it's less than 1, it represents decay. So that still applies. Just a little word of warning too as we do these, never multiply those two numbers together. 4 times 2 does equal 8, but because the 2 has an exponent on it, I'm not allowed to multiply before I work with that, so just don't make that an 8. Alright, the next thing I'm going to notice then, after I've noticed its growth, is how this graph has been shifted. Well, this number is in the exponent, so that's going to be my horizontal shift, and as we've talked about all year long, the horizontal shift does the opposite of what it says. So rather than moving it backwards to the left one, this is going to move all my points to the right one. And then this value at the end is going to be my k value. It's the number outside of the exponent, and that's going to be my vertical shift, and that'll move my graph up or down, and it'll do what it says, so it's going to move the graph down 3 spaces. Well, that's the number that I really care about. For example, when I go to state my domain, my range, and my asymptote, the only number that's going to change these from the basic ones we've taken a look at in previous videos is that number at the end. My domain is still all reals. That will never change. Even if you shift the graph left, right, up, and down, it's still going to be all reals. My asymptote, though, has changed locations. Recall that it's normally at the equation y equals 0. However, this time I've taken that horizontal line and I've moved it down 3 spaces, so my new asymptote's going to be at the line y equals -3. So again, that's the only thing I'm looking for. The question up here was which of these affect the asymptote. It's only the k value. If you have a number in the exponent, it will not change where the asymptote's located. My range then, recall, is going to be all the numbers that are above that asymptote. So in this case, it's y is greater than -3. And notice again, those two numbers are connected, just like before they were both zeros. This time they're both -3s. So let me go ahead and get a couple things drawn in for this graph. I've got the asymptote figured out. It's been moved down 3 spaces, so there's going to be the new equation of the asymptote, the line the graph's going to get really close to but not touch. I still need to find a couple points though. Now in the previous video we talked about that 0, a trick. It doesn't work after you have shifted the points around. There's a way to get it to work, and if you want to talk to me about it, we can certainly talk in class. Otherwise, as I mentioned, I'm going to rely heavily on my table on my calculator to graph these ones. So I have gone ahead and found some points on my table already. I found -1, -2 was a point. 0, -1 was a point, and you can obviously use whatever points you want to use. I'd recommend you don't use the decimals, and then some of these are going to get astronomically large, so don't use those because they'd be hard to graph. So there's a bunch that I can pick from. If I graph a couple of them, I'm going to graph -1, -2, that's right there. And if I plot the point 0, -1, that's right there. I can plot more if I want to. I can get that idea of that basic curve. It's going to flatten out, but not get completely flat by the asymptote. It's going to curve through those points, and I'll add arrows at both ends. So again, if you want to skip to the end of this video, I'm going to show you some things about how to set up that table or find that table, and some other interesting things about it. Otherwise, that's kind of all I need to do for this problem. And that big note is you want to find out what your vertical shift is, the number at the end. That's going to move your graph up or down and change your asymptote. Okay, so let's just real quick talk about this second one, but not even bother graphing it. This time I see that I'm looking at an exponential decay graph because my base value is a number less than 1. That's the only thing that's going to tell you whether it's growth or decay. I'll do domain, I'll do range, and I'll do asymptote. One more time. Domain is still all reals. The equation of the asymptote will only change if your graph has been moved up or down. I can see that this number in the exponent will affect my graph. It's going to move it left or right, though, opposite of what it says. So the graph has been moved left 1 space. Which doesn't affect my asymptote at all, but this number at the end does. That's what I'm looking for, the k value. That's going to move your graph up or down, and specifically, or more importantly, that's going to, so let me kind of divide those up, that's going to change your asymptote. So the asymptote has been moved down 2 spaces, so it's now at y equals -2, and the range is going to be all the values that are greater than -2. Okay, so that's how I'm going to shift these graphs around and how I'm going to change my asymptote and my range. Let's go ahead and look at a couple things on the calculator real quick if you want to see that part.